Alright, so for the second part of this quiz, it's asking you to do a momentum chart. Basically, the initial momentum, change in momentum, and final momentum. Marty, which is in light blue, the truck, which is in green, and back to black for total. Alright, so just gonna draw the graph. So there are two ways to do momentum charts. One way is to do coordinates, while another is to just do magnitudes. For this problem specifically, it's way easier to do coordinates, and that's the method I'll show you. Now let's look at the information within the question. Marty, the mass of him is still 1,000 kilograms. The initial state is that he is traveling north at 30 meters per second. So north at 30 meters per second. What this tells you is that its momentum, again, I'll write the equation. Momentum is mass times velocity. The initial momentum would be, writing it out in coordinates, be 0 for the x coordinate, because as you see here, there's no horizontal aspect at all. It's only going up and down, which is the y coordinate. So it would be 30,000 Newton seconds. It then tells you that after he gets in a collision, he is going to go west at 30 meters per second. So for final, going west, it's going like that for 30 meters per second. Now, if you look at the arrow, there's only a horizontal component. There's no vertical movement at all. It's only left and right. So now it's x that's going to be a factor. And also keep in mind that direction matters. So when you are writing a coordinate, since it's going to the left, just like a grid, the left is negative, whereas the right is positive. So this would be negative 30,000 Newton seconds. And then for the y, it's just simply 0 because has no vertical aspect at all. The problem also tells you about the truck. The truck is, its mass is 4,000 kilograms, and initially it is traveling west at 10 meters per second. So, like we've been doing, the momentum of this would be negative 40,000 and 0. Of course, this is in Newton seconds. So that's basically all the information we're given at this moment. But what you can see is that we have our answers for 1, for 2, and we also have a piece of the information for our truck. Now, what's important to know for this problem is that it's a closed system. Like the question has stated before, there's no friction that you're considering. There's only these two objects in the system. There's nothing else. So the energy that's being transferred is only between these two systems. Also on quizzes, if you ever have any doubts about this, you can try asking a TA or the professor. Not sure if they'll tell you or if they'll expect you to know, but it never hurts in asking. So it's going to be a 0 for the total change in momentum. Now, at this point, it's basically just like a puzzle. You just have to know the relationships of this momentum chart to really piece out everything. There's also many ways to do this, or the first thing I'm going to do is finding the total initial momentum. We are just adding up the initial momentums of the truck and Marty. P total of initial is equal to P initial of Marty and P initial of the truck. Now, this is why coordinates make this problem a lot easier, because now all you have to do is really just add up the respective axis. So it's simply the x-axis you add with the other x-axis, and then the y-axis you only add up with the y-axis. So let me just include units in there. Alright, so total, you're going to have negative 40,000 ns, and then 30,000 ns. And there you go. Alright, and from there, you see that the initial total momentum plus 0 equals the final total momentum. Basically telling you they're the same exact thing. So, just gonna paste that in there again. I'm going to find the change in momentum for Marty. The basic equation, sorry, I should have wrote this from the beginning, but the initial momentum plus the delta momentum, or the change in momentum, is the final momentum. If you rewrite this, it would be the change in momentum is equal to the final minus the initial. So, since we already have the coordinates, let's just do that. The change in momentum for Marty is equal to P final minus P initial. So this is the initial and this is the final. Right. Just be careful of the signs that you're dealing with. Now for the y-axis, since it's a 0, you have to subtract 30,000. So you'll just get negative 30,000. And there you go. You have your change in momentum. Alright, so now if you look at the graph, in the very center square, you'll see that the change of momentum for Marty plus the change in momentum for the truck has to equal to 0. This means that they're basically inverse of each other. We can essentially write delta P of the truck is equal to positive 30,000. I'm going to just start writing K because I'm tired of writing the zeros. And positive 30,000 for the y-axis as well. And just writing Newton seconds for the units so we don't forget. And finally, we have this last square, so the PF of the truck. And again, since we're doing coordinates, this shouldn't be too hard. Okay, here it is. Basically, at this point, all we're doing is just adding these values up. So, this should give you negative 10,000 Newton seconds, and then 30,000 Newton seconds. And there we go. P final of truck. You might think like, okay, we're done, right? But no, you're wrong. The question states that you have to write everything in magnitudes, and specifically the direction. However, trust me, it's very easy. Let's just start with the change for Marty. So if you have a component, it's very, 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 very easy to get to the magnitude as well as the direction. It's basically just vector addition. For the x component, since it's negative 30,000, it's an arrow going that way. For the y-axis, since it's a negative 30,000, it's an arrow going that way. So if you combine them, it gives you something like this, where this is 30,000, and then this is 30,000. And the total, or the magnitude, is this angle right here. This is the initial point, and then this is the final point. And then The magnitude is basically the arrow that connects those 2 points. Just for elaboration, this part is the x, and this part is the y. So, to many of you guys, this looks very familiar, right? This is a basic right triangle. What you can just do is the Pythagorean theorem. X squared is equal to 30,000 squared plus 30,000 squared. It is roughly 42426 newtons per second. Now we also have to find the angle. You are expected to know the sine, cosine, and tangent rules. Regardless of which theta you do, you're going to get the right angle, but you have to be careful of your reference point. So my theta is the one that's illustrated, and it's 45 degrees. Now, when I write in my final answer, I have to specify that it's going downwards, but I have to write out the theta as well as the angle that I am referring to, or the axis that is my reference point. So 45 degrees. And then also, of course, write in the magnitude, 2426 ns. You just do this for all the components that you've gotten to get full points on this part.